This is just one tougher example with the optimization word problem stuff. There are a lot of the real life stuff isn't quite as algebraically nice as some other problems there. So you're going to see the work for this gets a little bit more involved. We have videos helping you with the other homework problems there, with most of the homework problems there. So I encourage you to watch the other videos over the homework problems. Um, these are some formulas that we'll kind of need. The geometry formulas will be typically given to us there, but these are, I think, what we're going to be using throughout this homework there. And let's just do one example. So it says we have this industrial tank in the shape of this. We got a right circular cylinder and then hemispherical ends right there. So I'm thinking, I was at the grocery store the other day. I saw like a yogurt thing. It had like granola or nuts and stuff on the front, and maybe you could even put a compartment with something on the side there. Or if you turn it to the side, I'm thinking one of those diesel trucks that hold the gasoline, the fuel trucks, the silver ones that, are circular, or even like a pill capsule or something like that, the time release pill capsules, but something of that shape. We got this giant industrial tank. All right. So we got this shape, and then it says this tank must have a volume of 4,000 cubic feet. So that means that's the given of that problem. So we're given that the volume here is 4,000. And now what we got to do on our own is come up with the actual formulas using these guys up here. So the volume of the cylinder is going to be pi r squared h. And then the hemispherical ends, they're two hemispheres, but when you put them together, it's like one whole basketball. So when you put the ends together, it's one whole sphere. So I'm going to go plus 4/3 pi r cubed. And so right away, you see how this is a little bit more involved. This is our secondary equation. We're going to use that to help us the variables in our primary equation. So right now, we're just going to pause right there. What we want to do tells us the hemispherical ends cost twice as much as the size. Find the dimensions that will minimize the cost of making this tank right here. So what I'm going to do, I want to minimize the cost. Now, if you're going to use the materials to make the stuff, you're talking the surface area of that thing. So we're going to start off with some surface area, but if we're going to minimize the cost, you got to make sure you get dollar amounts involved right there. A common mistake is students sometimes want to think, oh, if I just minimize the surface area and use the least amount of material, then that's going to minimize the cost right there. Not always true. That would be true if everything costs the same, but the instant they start telling us things cost more than the other part, you need to get the dollar amounts in there, okay? So we're going to need to use this twice as much thing in there, but we're going to start off with the surface area. So for a cylinder, or so for the hemispherical ends right there, that's one whole sphere. So that's going to be 4 pi r squared, surface area of the ends, and then the surface area of the sides, that's the surface area of the cylinder part, the cylindrical part. So that's 2 pi r h. Now that's just the surface area formula. If they ask us to minimize the surface area, that's what I would minimize, but they ask us to minimize the cost. So here's the thing, if I ever give you dollar amounts, if I tell you it's $4 to make the sides, you would times this by 4. If I tell you it's $7 to make the hemispherical end, you would times this by 7. So keep that in mind. If I ever flat out give you dollar amounts, use those dollar amounts. But right now, all we're given, it costs twice as much for the hemispherical size. That's the 4 pi r squared. That's the spherical part. So which means you need to times this by 2. And this is our primary equation right here. This is what we need to minimize. So this is going to be the one that we take the derivative of and set that equal to 0 eventually. But remember, before we do that, we need to get this in terms of one variable. That's what we're going to use this for. Now, normally it doesn't matter which variable you solve for, but typically on these harder ones, there's going to be one variable that's going to be easier to solve for. So hopefully you recognize right there, the H is the guy that you want to solve for. You don't want to solve for the R over here. Even if you could manage to solve for the R over here, you got two R's to plug that into, whereas you only have the one H right there. So sometimes it matters right there. Sometimes it matters right there, which one is going to be easiest to solve for. So let's go ahead and let's take this equation, and I'm going to solve this for the H. So I'm going to subtract the 4/3 pi r cubed over, and I'm going to divide that by the pi r squared. Now that looks a little bit messy there. With the complex fractions, remember, we're always going to get rid of those complex fractions. So I'm going to simplify that, times the top and the bottom by the 3. Okay, so there's my h, and I am now going to take that and insert that in for the h right there into my primary equation. Now, what I kind of want to just write down, all right, is before you take a derivative, it's going to be very helpful if you break the stuff up. You want to try to break stuff up and not use a quotient rule. You want to use your easy power rule. And then after we take derivative, that's when we're going to put the stuff back together again. It's some Humpty Dumpty, right? We're going to put this thing back together again and get your one single fraction. And after you get your one single fraction, all we'll be concerned about is where is that top. We'll set that derivative equal to 0. So when it looks a little involved like this, we're going to simplify this. So one thing that I noticed is that right here, the pi's cancel out. This r cancels out with one of those r's. So you have just like a 3r on the bottom. So I'm going to take this 2, distribute it through the top. And then you're dividing it by the 3r on the bottom. You don't want to take the derivative right there. Now, good news is we do have our primary equation in terms of one variable already, but you don't want to take the derivative when it's that complicated. You want to break stuff up. So remember, when you have a monomial, you can do a that over that problem. So let's continue to break this up. 24 grand over 3 is going to be 8,000. It's going to be over r, but I know I'm going to get ready to take a derivative here, so I'm going to rewrite that as r to the -1, and then you're going to get minus 8/3. The r cubed over r will make that, the pi will carry down, and the r cubed over r will make that r squared right there. Now, right now you have things broken up, so sometimes I won't even see this next thing that'll help me out, and I'll just take the derivative right there, and then I'll see it in the next step. But notice that you got a pi r squared there and a pi r squared there. You're allowed to combine those like terms right there. So this 8 is really like 24 over 3. So if I take 24 over 3 minus the 8 over 3, I can combine that and make that 16 over 3 pi r squared plus this 8,000 r to the -1. So that's what I mean by breaking that stuff up before you take the derivative. You want stuff broken up like that because now when I take the derivative, it's going to be an easy derivative. I got everything in terms of one variable. And so now when I want to minimize this cost, I'm going to take the derivative now, set stuff equal to 0. So look how easy this derivative is. We're simply going to multiply by the power, decrease the power by 1, and then multiply by the power, decrease the power by 1. And when I get that r to the -2, I'm going to make that r to the +2 on the bottom. And then after you take the derivative, that's why I want you to put the stuff together. Get yourself one single fraction. That way we'll never, if we run to a weirder problem or something like that, we're never going to lose solutions on this thing. So I'm going to use 3r squared as the common denominator, which means I need to put like an r squared there and an r squared there. So that gives us 32 pi r cubed. And it's like I need to put a 3 there and then times that by 3. So that'll give us 24 grand up top. So there's my first derivative. Boom, I got put together. I got the one single fraction, right? And now we can go ahead and set this thing equal to 0. I don't care where it's undefined on these word problems. I just care where the top of that is equal to 0. So let's move the 24 grand over, divide by 32. And if I do that in one step, that'll give us pi r cubed is equal to 750. And then you're going to divide by pi and then cube root both sides. So the r is going to be the cubed root of 750 over pi. Now, in all these word problems, I want us to be able to get that exact answer on the very first thing that we find, okay? And then when we find the second dimension, we're gonna get the decimal approximation for this, plug in that decimal answer and get a decimal answer for the second thing right there. So we should always be able to get the exact answer for the very first thing we find. Sometimes it might just ask us for the exact radius that'll minimize the cost, and then we have that exact answer. But now for the second thing, sometimes I might plug it in, get the exact answer, but it's just nicer just to get the decimal answer right there, and that's all we'll need there. So this is, so I will get the decimal answer for this thing, which for this part, that means the R is gonna be about 6.204. and we're talking feet on that. And then the reason I always round to 3 numbers after the decimal, because when we do our AP test, they always require 3 numbers after the decimal right there. So I'm just going to try and develop good habits right there. And then what we could do is take that, plug that into the H equation, and then figure out what that H is. It's going to turn out that H is about, so I'm going to let you kind of just do that on your own. The H is going to be about 24.814 feet right there. And that's all they ask for is what the dimensions are. So we will have some other videos for you explaining how trying to help us out with these word problems. So you can just kind of watch those on your own pace there, and then we'll go through any questions that you have. Thank you.